Okay, so we're going to, last class I left off on talking about the multiple steps when you have multiple links in your chain when doing the chain rule. So I'm going to do a little bit more practice of this today. So we're going to find the derivative of y is equal to the log base 3 of 2 secant of 4x plus 3. So first thing I got to do is identify my outside and my inside function. So my inside function of logarithm would be that 2 sine of 4x plus 3. So I'm going to start always taking the derivative of the most outside. So the derivative of log base 3, well, the derivative of log is 1 over x times, and this x in this case is my entire inside function. Maybe this will make it where you can see it a little better. All right, so derivative of log base 3 of x is 1 over x, but x this time is my entire inside, times by the natural log of 3. And then, but I have an inside function, so now I got to take the derivative of this inside function. And so when I take the derivative of this inside function, I'm now taking the derivative of 2 secant of, and my new inside is that 4x plus 3. All right, so the derivative of 2 secant is 2 times, and the derivative of secant is secant of x, which is 4x plus 3 in this case, times the tangent of our x, which is 4x plus 3, and then times by the derivative of my inside, so my third link in the chain, and the inside's derivative is just 4. Now I'm just going to clean it up a little bit. So I'm going to multiply all the top together, so that'll give us 8 secant to the 4x plus 3 times tangent to the 4x plus 3 over 2 times secant of 4x plus 3 times by the natural log of 3. And then I notice, wait, I got multiplication of secant 4x plus 3 and multiplication of secant 4x plus 3 on the bottom, so I can cancel that out. And 8 divided by 2 is 4. So I can rewrite this as our derivative is equal to 4 tangent of 4x plus 3 divided by the natural log of 3. And that was 3 links, and we had to do the chain rule multiple times on that one. All right, here's a fun one. And I would highly suggest you to try pausing to see if you can do this. So what I'm going to do is I'm going to rewrite, before I take the derivative, I'm going to get rid of the square root by rewriting that as x to the 1/2 power. So each of these square roots becomes x to the 1/2. Be careful where you put your parentheses. It's very easy to get confused on this one. All right, so my inside function, my first inside function. Oh wait, let me check and make sure I have it written down correctly. Now that's the square root. Then I have all that inside underneath another square root. Okay, so it looks like I copied down correctly. It's so easy to get confused with the square roots on this one. All right, so now I'm going to identify my inside function. So I'm going to look at my most outer function, and that's something raised to the 1/2. So that means everything in that first set of parentheses is my inside function this time. So derivative of the outside is just a power rule. So I'm going to bring the power to the front, copy down what's in my inside, and then decrease the power by 1. So 1/2 minus 1 is 1/2. Now I'm going to times it by the derivative of our inside, okay? And so this time I'm taking the derivative of that outer set of parentheses, and it has a new inside function. And derivative of x is 1. And then here I got to do my chain rule again. So I'm going to bring the power to the front, copy down my inside, and decrease my power by 1. And then I'm going to times this expression, only this expression, that second half of that parentheses there, by 1 plus our derivative of our most inside function. And then close our parentheses. All right, so let's clean this up a little bit. The main thing I got to worry about is I can't have negative exponents and I can't have fraction powers. So I got to put my radicals back in. So that's all I'm going to do at this step. I'm just putting my radicals back in, changing my 1/2 exponents to the square roots. Let me write that without the parentheses. All right, so that's the first term. Times by 1 plus, and then this one I'm going to bring that, all of that x plus x to the 1/2 down to the bottom. Put it in underneath a radical. And I'm going to times this by 1 plus, and bring that radical down. All right. Okay, let's simplify this out. So I'm just going to simplify by first multiplying toward the end here. So I'm going to distribute this 1 over to square root of x plus square root of x to each of those two terms in the second parentheses, in the most inner parentheses. And now I'm going to distribute my first term to all 3 of those terms in my second parentheses. Okay, oh, this should be a plus sign in between these 2 terms. So all 3 terms should have plus signs in between. All right, so this is one way to simplify it. You can actually go farther and get a common denominator of all these fractions and combine them together. And that's enough. Once we got rid of our negative exponents and we got our radicals, we're good. So here's another one, but first, before I do this, I also need to rewrite it. So remember, this is sine of e to the x squared plus 4x minus 1, all of it raised to the cube. Let me fix those parentheses. All right, so take the derivative of the outside, so that's the power rule. So bring the 3 to the front, copy down everything that's in the inside. Decrease my power by 1. And now I'm going to take the derivative of the inside. So starting with the derivative of sine is cosine. Copy what's inside of it, inside that cosine function. Now the derivative of what's inside is e to the x. So that's going to, remember, derivative of e to the x is e to the x. And then I got to times it by the derivative of that polynomial, which is 2x plus 4. Cleaning up, all I can really do here is multiply the 3 times the 2x plus 4. Everything else, and I can bring that sine squared and put the sine by it and make it, instead of having sine quantity squared, write it sine squared. That's usually how we write our answers. But that's all I can really do. I think I'm going to need to put, let's put parentheses around our polynomial here, because it's all of that is times by it, not just the 12. There you go. That is how, so that's when you have multiple links in the chain. So once you got the chain rule down, and just remember, work with the outside first, and then just keep bringing the inside through, and then take the derivative of the inside till you get all the way in. Now I'm going to look at the derivative of inverse trig functions. And these are just some formulas that you need to memorize. Now, remember, I cannot have division by 0, so my answers, my x's have to be between -1 and 1. Oh, that should be exclusively. So should not include the -1 or 1, because that'll give us 0. And then I also can't have a negative underneath a square root. So that's the reason why we have to limit it. That's a funky looking one. Let's try it one more time. There you go. Okay. Remember that cosine and sine were closely related when we took the derivative of those trig function? That's true with inverse trig functions as well. Remember, cosine is c, so it has a negative, and it's just negative, the exact same formula for the inverse sine. Has the same limitations and everything. Okay, so you have to memorize the sine formula. You can just negate it for the cosine. Tangent formula is 1 over 1 plus x squared. And so cotangent is the exact same thing except with a negative in front. So it's going to be negative 1 over 1 plus x squared. Secant, the inverse of secant of x is equal to 1 over the absolute value of x times by the square root of x squared minus 1. This time our limitations of x so I get a positive underneath that square root and do not get division by 0 is that the absolute value of x has to be greater than 1. If you make a piecewise function out of that absolute value of x, it ends up being that we're looking at numbers less than -1 or greater than 1. Cosecant is the same formula. The inverse of cosecant of x has the same formula as the secant of x, except we negate it. So that's going to be, again, C is our hint that we're going to have negative answer. So negative 1 over the absolute value of x times by the square root of x squared minus 1. Now, these are often tied with chain rule. So I'm going to look at finding our derivative here of our inverse trig functions and apply with the chain rule as well. So the inverse of sine is 1 over the square root of 1 minus x, but this time my x is all of my inside function. So in place of x, I'm going to plug in x squared minus 1 and quantity squared. And now I got to times by the derivative of the inside, which is 2x. So we're going to simplify this down a little bit. So multiplying straight across gives me 2x. And then I want to figure out what x squared minus 1 times x squared minus 1 is by using our full method. You get 1 minus, I'm going to distribute the x as the negative as well. So 1 minus x to the 4th minus positive x squared, 2x squared, and negative 1. And then 1 minus 1 cancels out. So I'm left with the derivative with respect to x is 2x divided by the square root of 2x squared minus x to the 4th. We usually just write in that order because we want the positive term written first. There's no reason you could have kept it in the other order. Okay, here's another one. So I'm looking at my most outside function is cosine. So I'm going to start by taking the derivative of cosine, which is negative sine, and just copy down my inside function. And then I'm going to times it by the derivative of the arc sine of x, that's just another notation for our inverse of sine. And then I have no more inside function. So now multiplying straight across, I get negative sine of the arc sine of x divided by 1 minus x squared. Now, I can simplify this down. In order to simplify this down, we got to recall some information from college algebra. And remember that if we have inverse functions, then the f of g of x is equal to x and g of f of x is equal to x. So that's our kind of definition of inverse functions. That's how we verify two functions are inverses of each other. So notice on the numerator here, sine of the arc sine is sine of the inverse of sine of x. So that means that top expression simplifies down to simply x. So I could write this, my derivative is negative x over the square root of 1 minus x squared. Okay, now I'm going to take the derivative I'm going to find the derivative of the inverse of tangent of x squared. So first I do my formula for inverse tangent, which is 1 plus x, in this case x is x squared, quantity squared. So that's going to, and then times by the derivative of the inside, which is 2x. So that'll give us 2x divided by 1 plus x to the 4th. And that would be our derivative. Okay, last one I will do today is the derivative of the inverse of cosecant of x of 2x plus 1. So I'm going to use the formula for the cosecant. So it's negative 1 over the absolute value of x, which in this case is 2x plus 1, times by the square root of 2x plus 1 quantity squared minus 1. times by our derivative of our outside function, which looks like I forgot to write, so let's put that in, times by 2. All right, so that gives us 2 times the absolute value of x squared plus 1 and the square root. And then doing the full method here, we get x squared plus 4x plus 1 minus the 1 that's out there. Combining like terms, 1 minus 1 cancels out. So we just get negative 2 over the absolute value of x squared plus 1 times the square root of 4x squared plus 4. And that's it. We can't simplify that any farther. I mean, you could factor the 4 out and make a 2, and you could simplify the 2 with the 2 on top. But I'm not going to require that. So this is legit. Just know that if it's a multiple choice, it could have simplified slightly more. All right, so that is the end of the chain rule and the transcendental functions. So we had a lot of formulas in these sections. Hopefully that you're reviewing over it and studying so that you can do well on this section.